Hi, today we'll try and learn IUPAC naming for organic compounds. Now, the order of naming, which is the most fundamental thing to learn this, should always be word root followed by kind followed by functional group. Word root will tell you the number of carbon atoms in the principal chain. So if you have 1, then the word root will be meth. If you have 2, it will be eth, 3 prop, but, pent, hex, hept, oct, non, dec. After dec you have undec, dodec, but I don't think that will be coming in exam, so we can focus word root from starting from 1 to 10. Kind would indicate whether it's an alkane, alkene or alkyne, so we will be using ane for alkanes, or we have enes, or we have ynes. So ane, ene or yne indicating single bond, double bond or triple bond. The last thing that we write in a name is a functional group. Functional groups have certain specific endings which are called as suffixes. For example, an alcohol has a suffix of ol, an aldehyde has a suffix of al. This order is the key for IUPAC naming. You do not alter this order. Word root followed by kind followed by principal functional group. Let's say using this we have to name CH3 CH double bond CH CHOH CH3. The first thing that we identify when we are given any structure is the functional group. In this case, our functional group is alcohol. We will number the carbon chain in such a way that alcohol gets the lowest number. So I can number it from my left to right or right to left. I think this will give the lowest number 1, 2, 3, 4, 5. If you number the other way around, I think it will be 4. So the lowest number can be 2. That's why we number it from right to left. Now the principal chain of carbon has 5 carbons. So the word root that we have to select is pent. After pent we will stop and we have to find whether it's an ane, ene or yne. Since it contains one double bond, it is an alkene. The position of the double bond is indicated by using the lower number. If the double bond is between 3 and 4, we will write 3. If it is between 1 and 2, we will write 1. If it is between 6 and 7, we will write 6. In this case, the double bond is between 3 and 4, third and fourth carbon, so we will be using the lower number, that is 3. So we will say pent 3 ene. Every time an alphabet meets a number, you have to use a hyphen. So where again and number is meeting an alphabet, you have to use a hyphen in between this. Now next we have alcohol, which is at second position. So 3 things in this order: word root, this we have done, kind we have written. Now we are coming to functional group. Our functional group is alcohol, which is at second position, so it will be 2 ol. So pent 3, in, 2, ol. After word root, we cannot use two consecutive vowels A, E, I, O, U and Y as pseudo vowels, so they cannot come together. If we have this kind of a scenario, we have to cancel out the previous vowel. So since O is a vowel, we have to cut this E. So I'll be removing this E. Thus, in this case, my name becomes pen3n2ol. This is the correct answer to this structure. We'll try one more. Let's say we have CH3, C, triple bond C, CH2, CH2, C, double bond O, H. Now C, double bond O, H, this is an aldehyde. For aldehyde, the suffix we used is al. For alcohol we are using ol. For aldehyde we use al. Now in this case, aldehyde is the only functional group, so it will be preferred. Aldehyde is one functional group which contains carbon, so its carbon has to be included in the longest chain. If a group is preferred, it contains carbon, then its carbon has to be the part of the longest chain. So in this case, our numbering would be 1, 2, 3, 4, 5, 6. Hex, kind, you have triple bond, so it is ine between 4 and 5, so you'll write 4, hex 4, ine, E will get cancelled out with A, 1, al. Now if you look at these three things are in the specific order: word root, kind, functional group. Since A is vowel, we have cut the C, so hex 4 and 1 al. This is the name. Now in case we have multiple functional groups, let's say we have to name aldehyde is written as CHO. We have to name this. Now this contains CHO, which is an aldehyde, OH, which is an alcohol. It contains multiple functional groups. Out of these two groups, one will be preferred and it is termed as principal functional group. If you have aldehyde and alcohol, among these two, aldehyde is preferred. So when we are naming this, we will initially leave alcohol and name this. So you assume there is no alcohol and we try and name this. So aldehyde, it contains carbon, so its carbon will be included in the longest chain. So you have 1, 2, 3, 4, 5. So we write pent. Double bond is there between 2 and 3, so 2. E gets cancelled with A, 1 al. So it's pen 2 and 1 al. Now we have not written alcohol. Alcohol is present on 4th carbon. For alcohol we write hydroxy when it is not preferred. So for alcohol we wrote ol, ol when it was preferred. If you recall the first name that we did, we used OL for alcohol, but OL is used when it is preferred. If it is not preferred, we use hydroxy, which is called as prefix. Now this hydroxy is present on 4th carbon, so it will become 4 hydroxy pen-2N1-al. Now this means every group is going to have two names, one when it is preferred and the other one when it is not preferred. So if you look at this sequence, this table which is given to you, the groups are arranged according to their preference order. If you look at aldehyde, it is at 6th and alcohol is at 8th. Aldehyde is over alcohol. So if aldehyde and alcohol is present, aldehyde will be preferred over alcohol. When alcohol is not preferred, we are going to write hydroxy. When alcohol is preferred, we write ol. So same thing follows if you have multiple functional groups. Let's say next name has 4 groups. Out of those 4 groups, I will prefer one, and this table tells me my preference order. Acid comes at the top. This is acid. Then these 3 are acid derivatives. Then you have nitrile, aldehyde, ketone, alcohol, so on and so forth. Only one group can be preferred, and what is preferred is written at the end, which is called as suffix. Everything else will become prefix. Now for example, let's say we have in this case, we have 3 functional groups: aldehyde, chloro, and alcohol. Halogens are never preferred. So among aldehyde and alcohol, aldehyde is preferred. So you will leave these 2 groups initially and you start with the word root preferring aldehyde. So your sequence would be, order of numbering would be 1, 2, 3, 4, 5, 6, 7. That would mean it will be hept. Kind is ine. So this will be the end of the name after eliminating the vowel. Now we have not written alcohol. For alcohol we use hydroxy. For chloro we use chloro. It starts with C and this starts with H. C comes first in alphabetic order. The prefixes, something which is written before the word root, are always written in alphabetic order. So the name will be 5-chloro 6-hydroxy hept 3-ine-1-al. So when you are naming, just keep in mind, you always write the end first, starting with word root. Do not start from the beginning. You write word root, kind and preferred functional group, and then you write everything else in the beginning. Now ketones are represented as double bond O. So you have NH2 is amine, Let's say we have to name this. Now let's first see the functional groups which we have provided. So we have alcohol, bromo, chloro, keto and amine. These two halogens are not preferred, so they are out. Among amine, alcohol and keto, if you go to this table, this gives the preference order. Alcohols, amines, ketos. The ketones are most preferred, so we will leave and forget about others and try and give keto the lowest number. Now, if you observe, if we start from our left to right, it gets number 4. From right to left, it gets number 5. So we'll prefer this 1, 2, 3, 4, 5, 6, 7, 8. So you have oct. This will be your word root. There is no double bond and there is no triple bond, so it will be ane 4. For keto you write one. Octane 4 one. The E has been cut because of O. This will be the end of the name. Now there are 4 groups which you have not studied: amino, chloro, bromo, hydroxy. We are simply going to write these in alphabetic order. So it will be 2 amino, 7 bromo, 5 chloro, 8 hydroxy, oct and 4 one. 2 amino, 5 chloro, 7 bromo and 8 hydroxy. We are just putting them in alphabetic order. So A, then B, then C and then H. After that you are writing the word root followed by the principal functional group. Now in case we have an acid, certain groups, they are always at the end. An acid is like C double bond O OH. It is not possible that acid is in the middle of the carbon chain, because if you put it in the middle of a carbon chain, it will be C double bond O OH. Then this carbon will have 5 bonds, which is not possible. So acids are always at the end. They cannot be in the middle of the series. They are always at the end. They are called terminal groups. Aldehyde is also a terminal group. Aldehyde cannot be in the middle. Aldehyde is C double bond OH. If you try and put it in the middle, you will have to put 2 carbons along with this. Then this carbon will have 5 bonds, which is not possible. So acids, aldehydes, they are always at the end. They are also called as terminal groups. Now let's try and name this one. In this case, the functional groups which are given to us, COOH is acid, CHO aldehyde, OH is alcohol and double bond O is ketone. Acid is most preferred. Since it is carbon containing, its carbon will be included in the longest chain and it will be given priority. So numbering will start from 1, 2, 3, 4, 5. That will be pent. All single bonds between carbon, this will be pent N 1 oic acid. There will be space between oic and acid. Otherwise, in the entire organic name there is no space, but every time a number meets an alphabet or an alphabet meets a number, there has to be a hyphen. Now we have not written these three groups. Keto, we write oxo for keto. Hydroxy, for aldehyde we write formyl, F H O. So F comes first. So your name will be 3-formyl, 2-hydroxy, 4-oxo. For keto we write oxo. So 3-formyl, 2-hydroxy, 4-oxo, pentane 1 oic acid. The next functional group we study is nitrile. Nitrile is C triple bond N. Again, nitrile is always terminal. That means it can only be present at the end of the carbon chain. Now, let's say we have to name this. So we have bromo, chloro, bromo, keto and nitrile. Among these, nitrile is most preferred. So the numbering will begin in such a way that nitrile gets the lowest number, so it will be 1, 2, 3, 4, 5, 6. 6, so we write hex, all single bonds, hexane, 1 nitrile. For nitrile, the suffix is nitrile, so N is not a vowel, so E doesn't get cancelled out. Now we are left with 2 bromos, both are at position 4. A chloro, bromo starts with B, chloro with C. If there are 2 bromos, we will be using di, but we will not be including the D when we are deciding the order. Bromo will always come before chloro. The number of bromine does not determine the order. B will precede C. So your naming in this case will be 4, 4 dibromo. Although they are present on the same carbons, but you have to mention the position every time, and 2 numbers are separated by a comma. 4 dibromo, 3 chloro, 5 oxo. Now the vowels do not get cancelled. They are not cancelled before word root. If you look at chloro ends at O and oxo begins at O, you are not going to cancel the vowel. That thing only happens after the word root, not before the word root. So we have also studied nitrile. One other important rule, if you look at the top, these are carbon containing functional groups. Aldehyde upwards, all of them are supposed to be terminal, they will be at the end. Now if these groups are not preferred, their carbon should not be the part of the longest chain. We will take one example, in fact we will take two examples just to show this point, that if they are not preferred, we do not include their carbon in the longest chain. So let's take one simple example first. Let's say we have CH2 double bond CH, acid is most preferred, so we will circle the functional groups first. 1, 2, 3, 4, 5, 6. So you have hex 5 N 1 oic acid, hex for 6 carbons, N for double bond, there is a double bond here, oic acid for acid. Now you are left with chloro. CN when it is not preferred is cyno. Chloro starts with CH, oxo with O, so CH will come first, so it will be 2 chloro, 4 cyno, 3 oxo, hex 5 and 1 oic acid. Now we have written cyno for CN. Now let's say we have COOH acid, we're supposed to name this. Let's label the functional groups first. Acid, chloro, alcohol, nitrile. Now the common mistakes in this case would be primarily about the longest chain. Most students make a mistake of saying the longest chain will be 1, 2, 3, 4, 5. Now this is wrong. If you take the longest chain having 5 carbons, you will say 5 cyno. Cyno is written when CN is not preferred. CN is not attached to 5th carbon. In fact, it is attached to 4th carbon. The rule is very simple. If you have carbon containing functional group and it is not preferred, do not take its carbon in the longest chain. As simple as that. So just keep this in mind. If you are not preferring and it contains a carbon, do not include this in the longest chain. So your longest chain will not have 5 carbons, it will have only 4 carbons. Now we'll try and name this. We'll have but and 1 oic acid, 4 carbons but, all single bonds N. For acid we write oic acid. Now we're left with chloro C, cyano C, and alcohol H. So it will be three chloro, 4 cyano, 4 hydroxy. You don't have 5 cyano. Actually, cyano is attached to 4th carbon. Cyano means CN. CN is not attached to 5th carbon. It is attached to 4th carbon. A very typical name which can come in exam can be like this. So you have H, C double bond, CH2, C double bond O, CH2, C double bond O, OH. Now if you name this, on your left side you have an aldehyde, and on the right side you have an acid. Acid and aldehyde, acid is preferred. Aldehyde is not attached to 5th carbon, in fact it is attached to 4th carbon. So your order of numbering will be 1, 2, 3, 4. This carbon will not be included in the longest chain. So keto is as it is out. So it will be butane, 1 oic acid, but and 1 oic acid. So you have 4 formyl, 3 oxo. 4 formyl, 3 oxo, butane, 1 oic acid. Now we come to acid derivatives. They are called acid derivatives because they are derived from acid. So you have C double bond O, OH acid. Instead of this, if you have Cl, it becomes acid chloride or acyl chloride. So this is acid chloride and this is amide. And if you have C double bond O, O, R, where R is an alkyl group, it is ester. This will be dealing on later. Now, if you only have NH2, it is amine. But if you have CONH2, it becomes amide. The same way, if you only have OH, it is an alcohol. But if you have C double bond OH, it becomes an acid. So you have to look at all the atoms simultaneously to determine which functional group is given to you. Now acid chlorides, when they are preferred, we write oil chloride. For amides, we write amide. Since the preference order is up high, they are not given together. It's very rare that they will be given together to you. So the basic preference order that you have to memorize is acid, followed by acid derivatives, followed by nitrile, aldehyde, ketone. That you don't have to separately memorize the order within acid derivatives, it is not required. But since it is given to you, if you want, you can do it. Now, if we have, say, this is a very simple name. If you have COCl, this is acid chloride, this is alcohol, this is chloro, and this is chloro. Acid derivatives will be preferred, so it will be 1, 2, 3, 4, 5. So you have 5 pent and 1 oil chloride. Acid derivatives are written as oil chloride. Now, so you have 4, 4 dichloro, 3 hydroxy. Now we have basically gone through all the functional groups. Now we come to how we choose the longest chain and what happens to the part of hydrocarbon which is not the longest chain. If you say if this is your longest chain and you are left with CH3 outside this is called as an alkyl group. Alkyl groups, they are written as, if they have one carbon, it will become methyl. If you take the longest chain and your C2H5 is left out, it has how many carbons? 2. 2 carbons, you use the eth. For alkyl group you have YL, so it will become ethyl. Any hydrocarbon part which is not the part of the longest chain is termed as alkyl group. Now let's say we try and name this CONH2 is, this is amide, this is keto. Amide is preferred, so we'll try and make the longest chain. 1, 2, 3, 4. This can also, you can have this as 5 or this is 5, won't make a difference. So if this is 5, this is out, this becomes an alkyl group. You cannot jump, you cannot do 1, 2, 3, 4, 5 and jump to this, or you cannot repeat on the line. Otherwise it can go in any sequence, that is not important. You cannot jump or you cannot repeat on the line, that's the only rule. So CH3 is out, for this you write methyl, for keto you write oxo. So you will have 5 carbons, so it is pent and 1 amide, pentanamide, and you have 4 methyl, 3 oxo. So 4 you have methyl, 3 oxo, pentanamide, this is the name. Now in case, say you have to name let's say we have to name this. First thing is to identify the functional groups. So you have acid, amine, keto. Among all the functional groups, acid is given maximum preference. If I take the longest chain, it can be starting from this carbon. So if I start from this, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. But if I take this as the longest chain, I am missing out on the principal function group, which is acid. This is wrong, this is not possible. So in fact, the numbering has to start from acid itself, because it is the most preferred group. It is carbon containing, so this will be 1, 2, 3, 4, 5, 6, 7, 8. The rule is we have to take the longest chain along with the principal functional group. If I were to take 9 carbons, I was not taking the principal functional group, which will be wrong. I have to take principal functional group. So my longest chain has 8 carbons, not 9 carbons. If I take 8 carbons, these groups, these two, this methyl and keto, they are left out, and also amine. We'll start to name from acid. 8 carbons, oct. So your double bond between 3 and 4, 3 N 1 oic acid. Oct 8 3 N 1 oic acid. Word root kind function group. Now you're left with 2 methyls, keto, amino and ethyl. So A, E, M and O alphabetically, so it will be 3 amino, 2 ethyl, 6,6 dimethyl, 6 oxo. The vowel of oxo will not get cancelled out, because you do not cancel the vowels before word root. They are only cancelled after word root. So just go through this name once. It will be 3 amino, 2 ethyl, 6,6 dimethyl. It should be actually 5 oxo. The oxo is in 5th position. This 5th. I have written 6, so it will be 5 oxo oct 3 and 1 oic acid. Now, in case we have both double and triple bonds, say let's say we have to name this. It contains a double bond as well as a triple bond. So first we'll label the functional group. So it has alcohol, chloro. Alcohol is preferred, so we try and make the longest chain with alcohol. So it will be 1, 2, a lot of students have doubt. They say this should be 1, this carbon should be 1, because alcohol is not a carbon containing functional group. So alcohol does not contain carbon, so you have to take a carbon chain in such a way that alcohol gets the lowest number. So this will be 1. So this is out now. 7 carbons, hept. Now you have double bond as well as triple bond. So you first write double bond, hept 5 ene 3 ine 2 ol. Y is considered as vowel, so this E gets cancelled out. O is vowel, so this E gets cancelled out. For hept 5 and 3 ine 2 ol. Now we have 1 chloro, 5 methyl. If your name only contains double and triple bond, like something like this, you have C double bond, C, 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 triple bond C. If this has to be named, among double and triple bond, double is preferred. So the numbering will start from this end. It will be 1, 2, 3, 4, 5. Just keep this in mind, that if nothing else is there and double and triple bond is there, then double bond has a preference over triple bond.